Good morning, one and all. Myself, Shudipta Roy, Assistant Professor, Department of Pharmacology, Bengal School of Technology, is here today with a new video on CNS pharmacology. Today's topic is epilepsy and anti-epileptic drugs, part 1. So, let us begin with what is epilepsy. Epilepsy is a very common CNS disorder affecting about 0.5 to 1% of the population. The characteristic event in epilepsy is the seizure. Seizures are associated with episodic high-frequency discharge of impulses by a group of neurons in the brain. It starts as a local abnormal discharge and may then spread to other areas of the brain. The primary discharge and extent of spread determines the symptoms produced, which range from brief lapse of attention to convulsions lasting for several minutes with various odd behaviors. The symptoms produced depend upon the function of the region of the brain that is affected. Hence, we can say involvement of motor cortex causes convulsions, involvement of the hypothalamus causes peripheral autonomic discharges, and involvement of the reticular formation in the upper brain stem leads to loss of consciousness. Hence, we can summarize the definition of epilepsy to be a group of disorders of the central nervous system characterized by paroxysmal cerebral dysrhythmia manifesting as brief episodes called seizures with loss or disturbance of consciousness with or without characteristic body movements, that is convulsions, sensory or psychiatric phenomena. The underlying causes of seizures may include various neurologic diseases that ranges from infection to neoplasm and head injury. In some subgroups, heredity has proved to be a predominant factor. Single gene defects, usually of an autosomal dominant nature, involving genes coding for voltage-gated ion channels or GABA A receptors, has shown to account for familial generalized seizures, that is, the familial generalized epilepsies. So, we can say epilepsies are the central nervous system disorders that is characterized by seizures and convulsions, sometimes loss of consciousness, and sometimes there is no loss of consciousness. Well, I hope the terms seizures and convulsions are now clear to you. Is it? Okay, so now let's move on to the various types of epilepsies. Epilepsies can be broadly classified into generalized seizures and partial seizures. The clinical classification of epilepsy shows these broad two classes, that is generalized seizure and the second is partial seizures. Now, this generalized and partial can again be subdivided into certain types. The generalized contains the tonic-clonic seizures, the absence seizures, the atonic, myoclonic, and the infantile spasms, whereas the partial seizures contains simple partial seizures, complex partial seizures, simplex partial or complex partial seizures, secondarily generalized. Now, let us describe the types of generalized seizures. The very first type of generalized seizure is termed as the generalized tonic-clonic seizures and are also called the grand mal seizures. This has two phases. One is the tonic phase, another is the clonic phase. The tonic phase lasts around 1 minute, whereas the clonic phase lasts around 2 to 4 minutes in certain individuals. There is a sequence of events that occur in tonic-clonic seizures. The sequence is the feeling of aura followed by cry and unconsciousness, followed by the tonic spasm of all the body muscles, which lasts for about 1 minute, and then the clonic jerking that is followed by prolonged sleep and depression of all the CNS functions. The second type is called absence seizures and also termed as the petit mal seizures. These seizures are prevalent mostly in children and lasts about half minute. The children shows no or momentary loss of consciousness, no fall. The patient apparently freezes and stares in only one direction, and no muscular component or minimum bilateral jerking is present, or the blinking of eyes are also seen. The third one is termed as atonic seizures, which are also called akinetic epilepsies. In this case, brief loss of consciousness occurs with relaxation of all the muscles due to excessive inhibitory discharges. The patient may fall in this case. The next one is called the myoclonic seizures. In case of myoclonic seizures, there is shock-like momentary contraction of all the muscles of limb or the whole body. The myoclonic jerking may sometimes accompany any type of generalized seizure or partial seizure. The last one is called infantile spasms, which is not probably a type of seizure. What happens in this case? These are only seen in case of infants, and intermittent muscle spasms are seen, and which leads to progressive mental deterioration. With this, let us move on to the second type of epilepsies, that are partial seizures. Now, as told earlier, these partial seizures occur in a specific part of the brain and then either spreads to the whole brain or is limited to a small area. We will see the electroencephalograms of the human brain after explanation of these slides, and there we will differentiate between the EEG graphs of normal brain and that of generalized and partial seizures. There we will see that in case of partial seizures, how a specific site of the brain is only affected. The first one is called the simple partial seizures, or the SPS. In this case, there is sudden jerking of a group of muscles or a limb, and the seizures lasts from half to 1 minute. In this case, there is localized sensory disturbances, visual or auditory hallucinations, depending on the area of the cortex involved, and that is why this is also called cortical focal epilepsy. In simple partial seizures, the patient remains conscious and is also aware of the attack. The second type of partial seizures are called complex partial seizures, and in this case, the temporal lobe is affected. The attacks are that of confused behavior and dreamlike state, and the patient have purposeless movements. This lasts for 1 to 2 minutes, and there is impairment of consciousness. The patient cannot understand what has happened to him during the attack. So this is the basic difference between simple and partial. In case of simple, the patient is conscious and is aware of the attack, whereas in case of complex partial, the patient is not at all aware of the attack and there is impairment of the consciousness. The third type, simple partial or complex partial seizures, secondarily generalized, is characterized by a partial seizure which is then followed by a generalized tonic-clonic seizure, and there is loss of consciousness in this type of seizure. Well, I hope up to this, what is epilepsy, what are the underlying causes, and what are the types, you can already answer. So I hope you don't have any problem with this part. So let us move on to some electrograms or electroencephalograms of the human brain to distinguish between the normal rhythms and the seizure rhythms of the brain. The left hand side recordings show the recordings of that of a normal brain. Now here we can see that the three lobes of the human brain has been shown. One is the frontal lobe, another is the temporal lobe, and the occipital lobe. If we look into the recordings, this is the normal recording of a human brain of the various lobes, frontal, temporal, and occipital. The first comparison is with the normal brain and with that of a generalized seizure, that is of tonic-clonic type. Now, generalized seizures, as we have already told, involves the whole brain, including the reticular system, thus producing abnormal electrical activity throughout both the hemispheres. Here we can see that both the hemispheres are included and affected. The first one is that of a tonic-clonic seizure. Now, a tonic-clonic seizure consists of an initial strong contraction of the whole musculature, causing a rigid extensor spasm and an involuntary cry. Respiration stops and defecation, micturition, and salivation often occur. This tonic phase lasts for about 1 minute, during which the face is suffused and becomes blue. And this is followed by a series of violent synchronous jerks that occur and die about in 2 to 4 minutes. The patient stays unconscious for a few more minutes and then gradually recovers, feeling ill and confused. So, figure A represents the electroencephalogram of a normal brain, whereas in figure B, we can see the first number 1 represents the normal record, the second represents the onset of tonic phase, the third marks the clonic phase, and the last, the fourth, represents the post-convulsive coma. Thus, looking into the recordings of the brain in both the sides, frontal, temporal, and occipital of both the sides, we can now conclude that the difference between a normal EEG record and that of a generalized seizure tonic-clonic type. Now, I hope this is clear to you, and now tonic-clonic seizures are more better understood. Well, with that, let us move on to the difference between the electroencephalograms of tonic-clonic type and absence seizures. The absence seizures, as told, occurs only in children and are much less dramatic. The patient abruptly ceases from whatever he or she is doing, sometimes stops speaking in the mid-sentence and stares vacantly for a few seconds with little or no motor disturbances. They are unaware of their surroundings, and the electroencephalogram pattern shows a characteristic rhythmic discharge during the period of seizure. So this is the characteristic rhythmic discharge which occurs during the absence seizures. The rhythmicity appears to be due to oscillatory feedback between the cortex and the thalamus, the special properties of the thalamic neurons being dependent on the calcium channels that they express. Well, with that, we can now differentiate a normal brain, a brain with a tonic-clonic type of seizure, and a brain with a type of absence seizures. Now let us move on to the last segment of today's video, that is differentiation between a normal brain and that of a partial seizure brain. In case of partial seizures in the electroencephalogram, we can see the abnormal discharges occurring in the left frontal and temporal regions. Here we can see only the frontal and the temporal region of the left hemisphere has been attacked and not the right hemisphere. In this case, the discharge begins locally and often remains localized. The symptoms depend on the brain region, and regions involved may include involuntary muscle contractions, abnormal sensory experiences, or autonomic discharges. It may affect on mood and behavior, and that is why it is often termed as psychomotor epilepsy. The electroencephalograms in this type of epilepsy are normally confined to one hemisphere. Partial seizures can often be attributed to local cerebral lesions, and their incidence increases with age. In complex partial seizure, loss of consciousness may occur at the outset of the attack or somewhat later, when the discharge has spread from its site of origin to regions of the brain stem reticular formation. Thus, we can say the various types of seizures can be recognized on the basis of the nature and distribution of the abnormal discharge. Abnormal electrical activity during and following a seizure can be well detected by electroencephalography recording from electrodes distributed over the surface of the scalp. One of the important type of generalized seizures is that of status epilepticus, and it refers to the continuous uninterrupted seizures requiring emergency medical treatment. We will be studying about status epilepticus in broader sense when we go for the anti-epileptic drugs. So thank you for watching the video. I hope from this video we have all discussed and learned or brushed our knowledge a bit about epilepsies, its causes, its types, the differences between generalized and partial seizures, the types of generalized seizures, the types of partial seizures, their subtypes, and their electroencephalograms, which would help you to enhance or to enrich your knowledge regarding epilepsies. Thank you. I hope you liked the video. And for the anti-epileptic drugs, please wait till my new video comes on the top.